Welcome to today's tutorial where we will explore how to utilize artificial intelligence for predicting energy consumption. Now, this is a critical topic as energy conservation is becoming increasingly important in our day-to-day lives. In our session, we will be working with Java, so make sure you have your environment set up correctly. Let's start by discussing the prerequisites for our project. For today's tutorial, we will need the following tools: Java Development Kit, JDK, Apache Maven for dependency management, and an IDE like IntelliJ IDEA or Eclipse to write our code. Make sure you have everything installed and ready. First, we need to create a new Maven project for our energy consumption prediction. Open your IDE and create a new Maven project named Energy Consumption Prediction. Press Next and set the group ID to com.example and artifact ID to Energy Prediction. Once your project has been created, let's edit the pom.xml file to include the dependencies required for our AI and data handling. We will use libraries such as Weka for machine learning, JSON for JSON handling, and Apache Commons Math. Next, let's set up our directory structure. We will create a src/main/java folder for our Java classes and a src/main/resources folder for any properties files or datasets that we will be using. Under the resources folder, we will add a sample dataset named energy_data.csv. This dataset will contain energy consumption data over time. Here is a simplified version of what our energy_data.csv file might look like. You can create it in your resources folder and add the following data. Date, consumption, January 1st, 2023, 450. January 2nd, 2023, 470. January 3rd, 2023, 480. January 4th, 2023, 460. January 5th, 2023, 490. Now, let's create a class named Energy Data Loader which will be responsible for loading our dataset into our application. Create a new Java class in the src/main/java/com/example/directory and name it energy_data_loader.java. This class will read the CSV data and convert it into a format we can work with. We also need a simple model class called Energy Consumption Record to hold our data. Create a new file called energy_consumption_record.java in the same package. This will contain the date of consumption and the consumption value itself. Next, we will create a method to visualize this data. For simplicity, we will print the records to the console. Create a new class named energy_data_visualizer.java in the same directory. In this class, we will have a method that accepts a list of energy consumption record and prints the dates and consumption values. Now, we should integrate our loader and visualizer in the main method of a new class named main.java in the same package. This class will serve as the entry point for our application. We will load the data and then call our visualizer to print it out. At this point, let's run the main class. You should see the consumption data output in the console. This is a great starting point, but now we need to prepare this data for machine learning models. We'll use the Weka library to create a prediction model. First, let's define which features we want to use for prediction. For this model, we will create a feature set from our date and consumption values. We can create a feature that represents the number of days since the first entry. This unique feature will help the model learn trends over time. Let's modify our energy consumption record to include a day feature. Next, create a method called buildPredictionDataset in a new class datasetBuilder.java which will prepare the data for training our machine learning model. This method will convert our records into a format usable by Weka. Now we can add our dataset builder integration in our main method after the visualization step. We will build the training dataset and prepare it for the predictive model. We are getting close to implementing our machine learning model. Let's create our predictive model next. We will set up a linear regression model that will utilize the training data we just prepared. Update main.java again to include the Weka model. After running this code, it will train the model based on our previous records. The output will show the created model, indicating that our AI component is functioning properly. To predict future consumption values, we need a function to create an instance from new input. Let's extend the main.java file to add this functionality. We will predict the consumption for the next day based on the last entry provided. As we run this code, it will output the predicted consumption value for the following day after training the model on the existing data. You can adjust your dataset to see different predictions based on new entries. Finally, let's wrap up by creating a method to save the model, so it can be reused without being retrained each time. This will allow us to deploy the model more efficiently in the future. And there we have it. You now have a complete workflow from data loading, visualization, model creation, and even saving the model for future use. You've seen how easy it is to harness the power of AI for predicting energy consumption using Java. Before we finish, please consider exploring further into advanced models and more comprehensive datasets. By applying some additional features like weather statistics could improve your predictions significantly. I hope you enjoyed this video tutorial. If you found this information useful, please like, subscribe, and hit the notification bell for more AI and programming tutorials. Feel free to leave a comment with your thoughts or any additional questions you might have regarding today's topic.